All right, good morning, everyone. Thanks for joining us for another long coffee break edition. This week, we're going to be presenting on Daikin Pathfinder screw chillers and how we're able to lead the industry and part load efficiencies. My name is Nick Bryan. I work out of our Fort Collins office, and joining me today is Grayson Stubenhofer from Daikin to talk about our chillers. And with that, I'll hand it over to Grayson.
Hey guys. So yeah, today we're going to be going over the Pathfinder chiller from we're building these out of the Stanton plant, so that's where I'm from. I've been with Daikin for a few years now, and I came from James Madison University. So with that being said, we can get started on AWV. So I'm sure you guys have seen this before. This is just our line card for the PDC products that we have available today. We got AMZ, AGZ, and AWV. The top two are going to be Trailblazer. The AWV is Pathfinder, and that's what we're going to be talking to today. That is our flagship product, super configurable, really good efficiencies, all that. We'll talk more as we go through this today, but that is the product that we will be going over in this presentation. So just to get started here, just a couple code and credit items. So all the units will meet or exceed ASHRAE standard 90.1 2016. That unless you've rated it at conditions that are not under those conditions, but that's for another case. But normally you're going to be meeting that 90.1 without any issue. This also will cover 2013, and 2011 ASHRAE as well. All of the Pathfinders will be using R134A at the time. We'll be talking a little bit more about it later, but there's going to be another refrigerant that we'll have available by the end of the year. You can also meet LEED refrigerant credits with this unit, which helps with getting LEED credits for your buildings and LEED ratings. And then I mentioned a little bit, the configurable design is really what drives this product home and what keeps it as our flagship product, because you can mix and match your compressors, your evaporators, your number of condenser fans, your type of condenser fans, economizers, all that good stuff to get it exactly into the footprint electrical performance that you need for your job, which makes it really good for retrofitting. Okay, so like I mentioned, there's a lot of items on the configurability of this product. So here's just a slide that's going to outline those. You got 8 to 30 fan options. That makes the range of 100 to 565 tons. We've got the fully configurable fans in terms of fan numbers, as well as the DC and AC options on the package right now. You can also change your compressor speeds, your RPS. Rotations per second. You can also change your refrigerant economizers. There's an option for an integrated water side economizer. You can change your evaporators and your electrical as well to dial that in for your job. You've also got the micro channel construction, which is done in modular way with these V banks. So these V banks can be pulled out and serviced separately. And then we've also got the low sound options, which are in the form of the internal discharge compressor muffler, which is going to be standard. You also have sound wraps, and then you also have a sound enclosure option, which will all be selectable in Daikin tools. And then the main driver for the efficiency for this product is going to be the VVR technology, which is going to optimize your performance at any operating condition. And we'll go into the VVR now. So getting started on the VVR. So what you've got here is a little compressor cutaway of our screw compressor. So all of our screw products are going to have this VVR technology. That includes the water-cooled screw as well, WWV, but we'll stick to the AWV today. So before we get into VVR, actually, there's a little note here talking about the IDCM I mentioned, the internal discharge compressor muffler. That is this right here. It's pretty much the oil separator. But this extra mass helps a lot with reducing the discharge sound, the sound of the discharge of the compressor. This also would improve the efficiency of the compressor as a whole, because it's internal to the compressor. So on VVR, so what that's really doing for you is it's going to be varying your compression ratio and your volume ratio on the fly, so that you can optimize your operation at any given condition when your ambient temperature or your leaving water temperature are changing. So essentially, the old way that it was done was the way modulation was done was that there was a slide valve on the suction side of the compressor, which would control for capacity. And it would not be able to control for lift. It would only be able to control for the capacity. And now the new way that it's done is we have a slide valve on the discharge side of the screw, which will allow the compressor to vary for lift. It'll be able to modulate for lift conditions, and then the VFD will be modulating the mass flow rate of refrigerant through the compressor, which will be modulating for your capacity. So our compressor today is able to modulate for both lift and capacity simultaneously to optimize for part load conditions, whereas before you could only really modulate for your capacity, which doesn't give you nearly as much control, and it doesn't really handle the part load scenarios as good as the new technology. So here's just two quick definitions, just volume ratio and compression ratio. It's just the ratio before and after compression through the screw compressor. So nothing really too crazy going on here. So what is lift? I mentioned lift a little bit. Most of you are probably familiar, some may not, but lift is essentially just the difference between your condensing pressure and your evaporator pressure. So the top red line is going to be your ambient temperature. That is part of your condenser coils. It's a function of those. And then the evaporator is going to be, this blue line is going to be your leaving water temperature set point of your evaporator. So that difference is going to be your lift. And your compressor is what's doing that duty. It's getting that refrigerant pressure up to that condensing pressure for the unit. So what happens if your ambient temperature drops or your leaving evaporator water temperature rises and your compressor wouldn't need to work as hard? That's what the VVR is doing for you. It's going to help you out in those scenarios. So essentially the compressor is going to have to make up all this work to satisfy this lift condition. So the compressor does work, the change in enthalpy from state 1 to state 2. That's going to be your compressor work. And then when the ambient temperature drops, this is your new state point that your compressor needs to work to. It doesn't need to compress the refrigerant all the way to this 2. It can go to just here to 2 prime. So by reducing this lift, we effectively reduce the compressor work needed to meet that condition. So you can see the difference between H1 and H2 here in red, and then H2 and then, or H1 and H2 prime here in yellow. You can see the compressor work is a lot lower. Because of the VVR, we don't have to work as hard to meet that condition. You can't do this without VVR compressors because the volume ratio is fixed. You wouldn't be able to vary your volume ratio or your compression ratio along the screw. So with that being said, here's just what it kind of looks like. This is what a lower volume ratio looks like. The refrigerant is coming in from the left side, moving to the right. It's able to escape the flute of the screw earlier in a lower volume ratio scenario, whereas in a higher volume ratio scenario or a higher lift scenario, the discharge valve will move towards the discharge side of the screw, which would make the refrigerant escape later, thus compressing it further. Here's just a way to look at lift in a little bit of an easier way. So essentially, you're making it so that the VVR helps your compressor not work as hard. This is just another example that kind of puts it into the eyes of work. So say you're loading concrete or bags of sod or something into the back of a pickup truck or a truck that has a tailgate. You don't want to lift all of that material over the tailgate to get it into the bed of the truck, like in scenario 1. You're working too hard. In scenario 2, you've got the lift gate down and you can just drop your material right into the bed of the truck without doing the extra work. So you're gonna not work as hard to get the same job done. We can watch a quick little clip on the VVR.
In a traditional screw, when gas enters the flute of the screw, it gets compressed along the entire length and is also compressed at a fixed compression ratio. With VVR technology, a slide valve is added to the discharge side of the compressor, allowing us to vary the compression ratio by letting the gas escape sooner before it gets fully compressed. Unlike a traditional screw that uses a slide valve on the suction side of the compressor that modulates capacity and does so less efficiently, VVR technology uses a slide on the discharge side of the screw, which does not modulate capacity at all, only compression ratio. Rather, capacity is controlled through use of a variable frequency drive. The combination of a VFD to control capacity and a VVR slide to control compression ratio works together synergistically to optimize efficiency at any condition. VVR compression technology senses the precise amount of lift needed and adjusts the compression ratio on the fly to give the optimal efficiency at any operating condition.
Okay, so that's just another way to look at it, just to kind of keep it fresh in your mind, because that is a very important part of the Pathfinder. So reason why it's important, not only just because of the efficiency benefits, but it'll also help you exceed the requirements that ASHRAE 90.1 have for airside economizers. So 90.1 has these efficiencies listed that you need to meet to avoid the use of an economizer. And depending on where you are, which climate zone, you have to beat this base efficiency by 17 to 77% to be exempt from the economizer. So without VVR, you're not going to be able to meet these. You need VVR to meet these requirements. So oftentimes, just with VVR alone, you'll be able to meet these without any additional equipment. It would save you a lot of money because you wouldn't have to pay for the economizer. So here's just some more options for AWV. Here's the AC fan motor off to the right. Those are going to be not the standard, but there are just standard fan troll AC motors. Then there's DC fans, and then there's also VFD fans. So we'll talk about the VFD fans first. So the VFD fans are going to be one fan VFD on each circuit, and each of the fans are going to be tied together via contactors. So that's how they would be being modulated their speed. It'd all be based off of that first fan on the circuit that would have the VFD tied to it. Whereas in the DC scenario, they're all the fans are going to be tied to an EC module, which will vary the speeds of the fans individually. So it gives you a lot tighter control. Both options will allow for low ambient capability. You can run down to -20 Fahrenheit on AWV and start up down to -10. So if your temperature were to pass -10, you would, or go lower than -10, you wouldn't be able to turn the chiller off and start it up again until the temperature were to raise back up to above -10. And then last for this slide would be the condenser fan off to the right. That is our composite design for the AWV. It's not the standard aluminum like you're used to on AGZ. This is a fiberglass composite, and it has a little bit different wing swept design that helps with airflow and efficiency. And also helps with sound because it's not metal, it's a composite. All of our air-cooled chillers are going to have the micro-channel coils on them. They've got better performance than the tube and fin. They're easier to clean and they're more cost-effective. So that is why these are our choice today. Some of our competitors still offer tube and fin, but these benefits usually outweigh the positives of the tube and fin, like their durability. So yeah, and then we've got the epoxy coated coil option for anytime you enter 50 miles or less in DST, it'll automatically put the epoxy coated coils, and those are done via an E-dip. We'll skip that. That's just a test showing our aluminum alloy versus the standard aluminum alloy. Over 2,000 hours of a spray test, ours didn't see any breaking. Here's just a little more on the micro channels, just a closer look at the epoxy coils. All of the bottom rows of our coils are going to be dead so that when you're shipping or handling the coils, it lessens the chance of a catastrophic burst or leak. At the bottom of each header, you're going to have rubberized cups to help with vibration and also damage and corrosion. And also anywhere there's metal to metal contact where it's connected to the actual metal of the unit, the metal frame, then it'll also have a rubber gasket as well. Just a quick note on mission critical applications for AWV. AWV and AGZ are both good applications for mission critical, but here's what makes it extra beneficial is the rapid restore and fast loading. So our times are about half of that of our competitors. What the AWV controller is doing in a rapid restore or fast loading scenario is it's skipping the less important startup checklist items so that it can get the chiller online faster in the event of a power outage or power surge. So you can get that chiller back online and get that process or that building load, cooling load satisfied faster after a power event. And then another note is you can get leaving water temperatures up to 70 Fahrenheit on AWV, which is great for data centers or chilled beam applications, etc. Here's a little bit on the IWSE. So this is a new option from us. It's going to be a integrated water side economizer that you can use to leverage your ambient temperatures to offset your mechanical cooling load. We use a polypropylene pipe. Our competitors still are using metal in some scenarios, which helps us out a lot because the polypropylene's got a lower friction. It's got a lower pressure drop and reduced pump energy because of that. It's also very low weight. It doesn't corrode and it's UV rated. And the IWSE coils are going to be the same microchannel coils that we use for the refrigerant as well. They'll just be right up bumped up against it. Real quick, we'll go over the operation of free cooling. So you've got three modes: mechanical, hybrid, and water side economizer mode. The top right is mechanical mode, which is what you're used to, just your refrigerant running through your compressor and evaporator and condenser coils. Hybrid operation, you're first diverting the flow through the free cooling coils to pre-cool the fluid for the evaporator, which will make your compressor not have to work as hard. And then in integrated water side economizer mode or free cooling mode, you're bypassing the mechanical section completely and you're going only through the free cooling and the evaporator. So yeah, the chiller controller is going to be operating these valves based off of ambient temperature. So no intervention would be required there. So here's just a recap of Pathfinder. So industry leading IPLVs 22 plus, that'll be improved soon. I'll mention in the next slide, there's a few new options that we'll have. VVR technology is what's going to give us that real good efficiency. Widest tonnage range of any of our air-cooled products, 100 to 565 tons. And then the new water side economizer option is going to be really good for a lot of jobs that'll be beneficial. The rapid restore and fast loading, obviously for mission critical applications, and then the sheer configurability of the product is really good, is what's going to drive this one home and make this a good sell. And then it's been around for a while. The ALS has been around since 20 or so years ago, so it's built on a pretty reliable product line. So here's what the future looks like for Pathfinder while we got a few more minutes. So the remaining IWSE models will be available by the end of the year. Right now we got 12, 22, and 30, but by the end of the year, the 14, 20, and then 24 to 28 will be available. We'll have integral pump packages available on the 12, 22, and 30 fan models. If any of you were at DGSM, you got to see the 12 fan model with the integral pump package. We'll also have the EC module fans or the DC fans for the integrated water side economizers units, and then also we will have PM compressor motors, which will help a lot with full load efficiency and part load efficiency. And then we'll have the 513A as an option, as another refrigerant option. And the PM compressor motors will roll out at the same time because that option is essentially supposed to be making up for the loss in efficiency from using 513A, which is about 4%. So with 134A, you can expect with PM compressor motors about a bonus of about 4% efficiency. So yeah, with that being said, I'll turn it back over to you guys at Long. Thanks, guys.
And please join us next week where Sean Davenport Smith will be talking about air separators and what they can do to help drive down costs in your building. Thanks, everyone.